Hello friends, today we are going to discuss few things about phenolophthalein and we will discuss few questions also. So let's start friends. In the very beginning we will see what is the structure of phenolophthalein. So you will find four answer options on the screen. So friends, you have to choose the correct one. Which of the following is the correct structure of phenolophthalein? Yes friends, answer option D. Answer option D is the correct structure of phenolophthalein. तो फ्रेंड्स, ये phenolophthalein सिंथेसाइज कैसे होता है इसकी ओर हम बढ़ेंगे. फ्रेंड्स, phenolophthalein is synthesized by using phthalic anhydride and two molecules of phenol. When phenolophthalein is synthesized, what exactly happens? Phthalic anhydride is reacted with phenol in presence of acid, and the reaction mixture is slightly heated and the phenolophthalein is synthesized. If you observe the structure of phenolophthalein, I will rewrite this structure for your better understanding. Here one oxygen is attached and the second oxygen is substituted by phenol group. The pH is phenol group. Phenol is attached to this carbon atom at the para position, and that is nothing but the phenolophthalein. Phthalic anhydride is reacted with 2 moles of phenol in presence of H2SO4 acid. In acidic medium this reaction takes place. So friends, for better understanding and to make this reaction more clear, we will look the mechanism of this reaction. So friends, just a moment friends. So what exactly must be happening in the reaction mechanism? Here we are dealing with two molecules. One is phthalic anhydride and the other is phenol. So what might be happening? This is the phthalic anhydride. So what must be happening in presence of acid? Acid क्या देगा? Acid will give H plus ion. Now this H plus will attack at the place where the electron density is more. So basically there are 3 oxygens which are available, which can donate electrons to this proton. But friends, if you observe this oxygen atom in the resonance, electron density is maximum on these 2 oxygen atoms. Both these oxygen atoms are similar. If we observe the chemical structure of phthalic anhydride, both are equivalent positions. So this H plus can attack on either of the positions. So this H plus will attack first on this oxygen atom. This negative charge comes over here and this lone pair shifts here and double bond is formed in this carbon and oxygen. Now friends, if we observe the resonating structures of this intermediate, this is the intermediate formed during the synthesis of phthalic anhydride. This negative charge can shift on this oxygen atom also. See, wherever you find conjugation in between lone pair sigma bond and pi bond, or lone pair sigma bond and lone pair, resonance will takes place. Here conjugation is there, this is the double bond, sigma bond and lone pair. So the other resonating structure of this intermediate, here comes the OH, this oxygen will have negative charge and this carbon will have positive charge. So friends, phenol, as we all know, OH is the electron donating group and activates ortho and para positions. Now the para position will attack more favorably on this carbon atom, because ortho position will become, this position will be sterically hindered. Hence para position is more favorable for attacking on this position. So what happens, this electron shifts over here and positive charge comes here, and the phenol molecule will attack on this carbon atom and gets attached at para position. So the next structure will be like this, COH, and here attaches the phenol molecule, which will have plus charge over here and double bond over here. In this way this will get attached. Now what next should happen over here, friends? Here oxygen has excuse me friends, this oxygen will not have any charge because already it is positively charged. When this pi electron shifts over here, this becomes neutral. There was a small mistake, correct it. So friends, here we have positive charge on the phenol ring. Now what happens, the hydrogen atom present over here, this leaves behind the electron pair and this phenol ring regains its aromaticity. This positive charge also becomes neutral and it regains its aromaticity. Here one OH is there, and now this hydrogen leaves behind the lone pair. यहाँ से H plus चला गया, तो this double bond comes over here and in this way one phenol group got attached to the phthalic anhydride. What happens in the next step? In the next step, the other H plus ion protonates this OH group. The other H plus ion protonates this OH. I will write this phenol group as PH in the next structure, because it is becoming very bulky structure and cumbersome to draw in that position. अभी इधर क्या हो रहा है friends? The other phenol group, the other OH group इज गेटिंग प्रोटोनेटेड, क्योंकि हमारे पास एसिड तो है ही. आफ्टर प्रोटोनेशन वी विल हैव structure like this and positive charge on this carbon atom, and this takes the bonded pair and water is removed from the molecule and plus charge comes over here, and in the similar manner the second phenol molecule gets attached on this carbon atom and phenolophthalein is formed. So this was the reaction mechanism of the phenolophthalein synthesis. तो फ्रेंड्स, अगर किसी रिएक्शन मिक्सचर में फिनॉल है, if phenol is present in any reaction mixture, so it should react with phthalic anhydride in acidic medium upon heating. Agreed? However, if the phenol is substituted at para position, if it has any substituent at para position, will it react with phthalic anhydride? No, it won't react, because para position is blocked. For this to react with phthalic anhydride, para position has to be free. para position free नहीं है तो phthalic anhydride से reaction नहीं होगी, और para position free है तभी ये थैलिक एनहाइड्राइड से रिएक्ट होकर फिनोलफ्थैलिन देगा, और फिनोलफ्थैलिन अगर हम बेस में किसी डालेंगे तो हमें पिंक या रेड कलर मिलना चाहिए. दैट इज, इफ द फिनॉल इज सब्सटीट्यूटेड एट पैरा पोजिशन इट वोंट शो थैलिन डाई टेस्ट. इसी को क्या कहा जाता है दोस्तों? व्हेन phenol is reacted with phthalic anhydride in acidic medium, it gives phenolphthalein, and in presence of base it colorizes to red. And if the phenol is substituted at para position, it won't show such coloration. phenol की टेस्ट हम कर सकते हैं इससे, if and only if phenol is free at para position. otherwise this test will not वर्क. अभी ये कलर कैसे आता है ये देखते हैं हम लोग दोस्तों. कलर डाई की वजह से आता है, तो ये इन प्रेजेंस ऑफ बेस थैलिक एनाइड्राइड गिव्स अ डाई एनायोनिक डाई. तो ये डाई कैसे बनता है ये देखते हैं दोस्तों. चलो आगे बढ़ते हैं. हमने अभी क्या देखा है? सिंथेसिस ऑफ फिनोलफ्थैलिन एंड उसका मैकेनिज्म. अभी बेस में बेस क्या करेगा? बेस OH माइनस देगा. OH माइनस जैसे ही रिएक्शन में उतरेगा वो किसे ढूंढेगा? H प्लस को ढूंढेगा. अभी इधर दो एसिडिक हाइड्रोजन्स है, इधर भी है और इधर भी है, तो ये दोनों हाइड्रोजन को चुरा लेगा. इन दो हाइड्रोजन को जब ये चुरा लेगा तो इधर क्या आएगा? नेगेटिव चार्ज आएगा. पहले वाले हाइड्रोजन के साथ क्या होता है ये देखेंगे. जब इधर नेगेटिव चार्ज आ जाएगा तो ये ऐसे जो इलेक्ट्रॉन पेयर है शिफ्ट होगी और इधर डबल बॉन्ड आएगा. जैसे ही इधर डबल बॉन्ड आएगा ये वाला डबल बॉन्ड किधर आगे शिफ्ट होगा. ये आगे शिफ्ट हो गया तो इधर वाला डबल बॉन्ड इधर शिफ्ट होगा. एंड इन दिस वे दिस रिंग ब्रेक्स फ्रॉम हियर. इधर का बॉन्डेड पेयर शिफ्ट्स ऑन ऑक्सीजन एटम, एंड on this oxygen a negative charge comes and this ring breaks and the dianion forms. This is the first anion formed after the attack of first OH minus. In the similar manner second OH group comes here and abstracts hydrogen from here and negative charge comes over here, and the final structure formed is like this. Here ring is here there was a bond before. This bond has broken and negative charge comes over here. I will erase this. Double bond came here. This double bond shifted from this position to this position. Here it is represented, and the double bond which came here is this. Okay friends, I hope the reaction mechanism is clear to everyone, and negative charge is present on these two positions. This is the first and this is the second. So this is dianion and it is red in color, and it is red in color. This will be obtained if and only if the phenol present in the reaction mixture has vacant para position, and if it has no substituent on this para position, तभी ये phthalene test देगा. चलो, on this concept we will see one more question. 4 structures are mentioned on your screen. So which of the following structure or which of the following phenol will not give phthalene dye test? Yes friends, answer option C, because the para position is blocked. Methyl group is present at the para position, therefore this will not show phthalene dye test. Okay friends, in today's session what all things we have discussed, we have seen what is phenolophthalein. उसके स्ट्रक्चर के साथ हमने शुरुआत की थी. phenolophthalein क्या होता है, phenolophthalein का स्ट्रक्चर क्या होता है, then how phenolophthalein is synthesized. It is synthesized from phthalic anhydride and phenol in presence of acid, and we have seen the mechanism behind this reaction. After that we have seen how the coloration is formed in presence of base. How phenolophthalein gives color in presence of base. This dianionic part is formed in presence of base, which is red in color, and this coloration is observed only if phenol is not substituted at para position. This was the question on that concept. Okay friends, thank you, thanks a lot. This was brief concept about phenolophthalein. I hope it is clear to everyone. Thank you, thanks a lot.